Hello, in this video I'm going to give a brief biographical background to Paul Dirac, one of the pioneers of quantum mechanics and quantum electrodynamics. So Dirac, he was born in Bristol. He had a Swiss father and his mother was from Cornwall, so from the southwest of England. He born in Bristol. Yeah, he also went to university in Bristol. That's where he did his degree in engineering. He was something of a maths guru, really. He was extremely proficient at maths, and he went on to Cambridge to do his PhD, which was actually the first ever PhD in quantum mechanics. So this was right at the cutting edge of the time. And he stayed at Cambridge to become professor of mathematics. Later on, he ended up moving to the US. I mean, he went to Florida. He was professor of physics at Florida State University, then Miami University. But he had a real mathematical emphasis on his work, and he often used the idea of mathematical beauty as a way of sort of choosing which paths to take forwards, in order to identify the path he was going to take in his research. Beauty was a key signpost for him. He won he was awarded the Nobel Prize for Physics in 1933. He shared that with Schrödinger, another one of the pioneers of quantum mechanics. And before then, he had already created the Dirac equation in 1928, which is possibly his most famous achievement. So this is looking at the equation of motion of what's known as the wave function of an electron. So when you're dealing in quantum mechanics, we're looking at probabilities, the behavior, the position, the motion of an electron is then described by what's known as a wave function, which is sort of encapsulating the probabilities associated with the behavior of the electron. And the Dirac equation it describes the motion of this wave function. So rather than just talking about the motion of a particle, like a billiard ball style particle, the Dirac equation talks about the motion of this probabilistic, if that's the right way to say it, probabilistic wave function. And it was from this work that Dirac then predicted the existence of the antimatter equivalent of the electron, the positron. A few years after that, he also predicted the existence of magnetic monopoles as a way of explaining why electric charge is quantized in chunks. Everything goes up in multiples of the charge of an electron. No one thus far, in nearly 100 years later, has actually found one of these magnetic monopoles, but it's still an idea which has got some traction nowadays. So he had made both of these advances prior to being awarded the Nobel Prize in 1933. Of course, in other videos, I've mentioned him in Fermi-Dirac statistics for describing fermions and how they behave en masse in this sort of non-interacting equivalent of an ideal gas. So yeah, he certainly contributed to statistical mechanics in that way as well. Although, even though they're named after him, or partly named after him, alongside Fermi, he always referred to the Fermi-Dirac statistics as the Fermi statistics and left his name out of it throughout his career. So yeah, he was quite a modest chap in that respect. He was also known for being quite taciturn. He was a man of few words, and jokingly, when he was at Cambridge, apparently his colleagues coined the unit of the Dirac as being equal to 1 word spoken per hour. But there you go. I mean, a remarkable guy. I mean, Stephen Hawking said of Dirac that he was second only to Einstein in his impact on 20th century physics. So yeah, really remarkable man, and once again, someone well worth knowing about.